So lesson 29 is going to talk about writing linear equations. We've done it from graphs and we've done it from tables. Today we're going to talk about table word problems.
And as we go through this problem, we've got this new plan of attack that we've created to help you solve really any type of problem. The first step in this new plan is to overview the problem. So while I'm reading through this, I want you to try to answer these two questions.
Rob is looking at gym memberships. Below is a table of the following memberships that 24-Hour Fitness offers. We have Basic, cost to join 35, monthly fees 15. Premium, cost to join 40, monthly fees 15. Deluxe, cost to join 50, monthly fees 20. The cost to join is a one-time payment to sign up as a member. The monthly fee refers to the cost to continue membership each month. Create an equation for each membership option. Type each equation in slope-intercept form.
Good, so you can see that right away at the beginning we know what the problem is about. The problem is about Rob buying a gym membership. And then what was the problem asking us to do, or what is it asking us for? Well, that was kind of given to us at the end when it said create an equation. So we know that we're going to create 3 equations because there's 3 different membership options.
So now we're going to break down the problem. The way we start is by identifying the model. Now, it's nice because the last thing that it asks us to do is to type each equation in slope-intercept form. Well, that's our model. It gave us our model. That won't always happen, but in this case it has. We're going to identify and define key information. The numbers that we need to define are really organized nicely in a table. So the unknowns we're going to talk about come from our model. What is this talking about again? Well, it's talking about a gym membership, which is associated with some cost. So we know that there's something we don't know about cost. Also, as we think about what we don't know about cost, we kind of look at these columns. We see there's a cost to join. Okay, that's about cost. There are monthly fees. That's about cost, but it also mentions something about monthly, which indicates that there might be something about time that we don't really know. So what is it about time and cost that we don't know? Well, we don't really know how many months we're going to attend. There's some people who sign up for gym passes, who shall remain nameless, and don't really attend the gym. And so after a little while, they cancel their gym membership because they know they're wasting money and they're just getting larger. And so we don't know how the number of months. We don't know how many months we'll attend because we might cancel because we're not attending it. And until we know the number of months, we don't really know what the total cost is. So we have the number of months, we have the total cost, which we don't know, and we're going to use our model to create a plan of attack.
And what we know about the model is there's 2 variables, x and y, and because there's 2 variables, one of them is independent and one of them is dependent, and y always represents that dependent variable and x always represents that independent variable. So as you think about the 2 things that we don't know, think about how they relate to each other. So which one of these could be the independent variable and which of them could be the dependent variable?
When you think about independent, you think about those kids who are like, nobody can tell me what to do. I'll do what I want. Well, as we think about which of these 2 things actually gets to do what they want, is it time or is it money? Well, no, money depends on a lot of things, right? In our particular scenario, it depends on how many months you go, is how much money you spend. But time doesn't depend on anything. It's completely independent. We can't stop it. We can't slow it down. We can't turn it back. So within our model, we've identified that x, the independent variable, is the number of months, and y, the dependent variable, depends on how many months we go to find the total cost. So we're going to jump straight into solving for the missing information. We know what x and y are going to be as unknowns. We do not know what m and b are. So let's think about that. We have x over here, which is our we have x over here, which is our number of months. What changes based on the months? Well, if x is 1, our m is going to be $15. So if I go 1 month, I pay $15. If I go 2 months, now I pay $30. So what is changing with the months? Our monthly fee is how much we end up paying total in monthly fees. So our change in y over change in x, dollars per month. Our b is really indicated by this table as well, which is nice. It's our initial cost. It's our constant. What is our constant or our initial cost? It's our one-time payment to join. So now we begin to execute this plan.
And when you're executing the plan, you're just using the model to do one of these various things. But we know what we're doing specifically is we're creating. And now what we're going to do is just figure out what we need to put into our model, which we've already done in the last slide. Well, we know that we need to know what M is for each membership option. We need to know what B is for each membership option. And we know that for the M value, we're using cost a month, and for the B value, we're using cost to join.
So the way, if I was talking about this, that I would read this, I would say, well, for a basic membership plan, your total cost, which we don't know, so we use Y still, is equal to $15 per month plus the $35 membership fee, $35 startup fee cost to join. And we can continue filling out this table, 15 and 40 for a premium plan, $20 monthly fees plus a $50 cost to join for the deluxe plan. So we have the total cost of a premium plan is $15 per month plus $40 startup, and for a deluxe plan, the total cost is $20 per month plus $50 startup. We're keeping Y and X because we still don't know them until life has already happened.
Good, and now we're here to the last part in the process, which is just closing out the problem. And when we close out the problem, we're just making sure that the stuff that we put into the model doesn't have any errors. And when we put it into Schoology, which has always been a stumbling block for us, that we're checking our answer and making sure that it's put in appropriately and accurately, right? So if we're typing in for the basic membership, we're going to start with Y equals the rate, which is $15, times the number of months that we go, which is X, plus $35 to sign up. And then for the premium membership, we know that the total cost, Y, equals the rate, which is $15 a month, times the number of months we go, plus $15. Well,
he meant to say 40. 15 is the rate of change, 40 is the cost to join.
And then the last one, the deluxe membership, is $20 a month, times the number of months we go, plus $50 to sign up. And that's really all we're doing. We've made sure that we've put in our rate at the right spot, and we've made sure that our constant goes at the end where the y-intercept would go. And we've done Rob a huge favor. We've created 3 equations for him, so now he can kind of mess around with the numbers to figure out which of these 3 plans is best suited for how long and how often he wants to attend. So let's move on to example 2, and as we go through this one, we're going to again use the process that we outlined. So we're going to first start by overviewing the problem. And while I read this, think about what it's about and what it's asking for. So Russell, in an attempt to satisfy his hunger, decides to try a new sub shop, Dan's Subs. And Dan's offers 3 different size subs and hundreds of toppings. The table below reflects the cost for a sub. And then it gives us this table, and it says cable plans, but it shouldn't say table plans. It should say something about subs. And then it goes on to say that the size of the sub is the base price, and each sub includes 2 toppings in the base price. And the cost for additional toppings varies, and it should probably say based on the number of toppings. Create an equation for each sub option and type each equation in slope-intercept form. So again, what is it about? Well, that was given to us at the beginning. It's about Russell and his attempt to satisfy his hunger by eating at Dan's. And what is it asking us for? Well, again, it's asking us to create an equation. So now we can get to the break it down part. And when we break it down, what we're going to do is identify the model. Well, the model, again, was kind of already identified for us. We know that we're going to use slope-intercept form, so we're operating with y equals mx plus b. And now we're going to identify what the numbers are. Well, there's 2 tables of numbers, and this first column we're talking about the base price of the sub. So if I want to buy a Hagrid sub, I know that I'm going to have to pay $8.35, and included in that price, remember, we got 2 free toppings. And then the second column of numbers, this cost for additional toppings. Well, this is going to be the cost to add toppings on to the 2 that we already get. So after 2, we're going to have to start paying either 25 cents if we're buying the Frodo, or 35 cents a topping if we're getting the Hagrid. So we know what the numbers are. Well, what are the unknowns? And the easiest way to figure out what the unknowns are in the slope-intercept model is to figure out the 2 things that are being measured. Well, if you think about the problem, if Russell's going to dance to satisfy his hunger, we know that one of those 2 things is food, and it looks like from the table we've got dollars, we've got cost, so we know that the second thing has got to be cost. Well, what do we not know about the food? Well, we don't know about what size he's going to get, but we know how much those sizes are, so we understand that. Well, we don't know exactly how hungry Russell is, so we can't identify how many toppings. So what do we not know about food? We don't know the number of toppings that he's going to put on his sub. And what do we not know about cost? Well, we know how much the sub base price is, and we know how much each topping is going to cost, but because we don't know the number of toppings, we don't know the total cost of the sub. And so now the next part is just put in what we know about the model. We've got our 2 unknowns here that have been identified as the number of toppings and the total cost, and we know that x is the independent variable and y is the dependent variable. Well, which of these 2 is dependent on the other? Well, if you think about it, total cost is dependent on the number of toppings we get. The number of toppings does not depend on the total cost. The total cost depends on the number of toppings. So we know that the total cost here is going to be y, and the number of toppings is going to be x. So now we've got to figure out what m and b are. We identified m as the change in y over the change in x. So what's changing, or how is the y variable, or how is total cost being measured? Well, the units it's measuring is dollars, and the units that x variable is being measured in is toppings. So we know that the rate here is going to be dollars over toppings. So if we look at the 2 columns, which of the 2 columns reflects this dollars over toppings idea? Well, this base price doesn't seem like it has anything to do with toppings, so we know that it's not this one. But this column right here, cost for additional toppings, this does have both dollars and toppings involved, and we know that it has some rate of change element to it. So we know that this 3rd column is our m value, and then our b value is always our constant. And so if we look at the first column of numbers again, the sub base price for the Joe, it's going to be $6.37. For the Hagrid, it's going to be $8.35. We know that this price does not change, so we know that the B value is this sub base price. And so once we know what M and B are, we can move on to the 3rd part in this process, which is to execute the plan for solving. So we're going to execute the plan right now, and we know that the rate of change, our M value, is the cost for additional toppings. So for the Frodo, we know that the total cost equals the price per topping, which is 25 cents, times the number of toppings that we get, plus the base price for the sub size, which is $5.53. And for the Joe and the Hagrid, why don't you think about and fill in your guided notes what the rate is for the Joe and what the Hagrid is for the Hagrid, sorry. And you're using the row that corresponds for Joe to find rate. We know that it's going to be 25 cents. So if we're thinking about the Joe, times the number of toppings we get, plus the $6.37 it costs to buy the sub size, equals our total cost. And then for the Hagrid, we know that the total cost is based on 35 cents times the number of toppings we get after 2. Remember, we get 2 free ones in the base price, plus the base price, which is the size of the sub, is $8.35. And then what we're going to do here is just allow you guys to type in blank 1, blank 2, and blank 3 the equation for each option.